G'day, mates. We're here to talk about HPA, eh? God, I can't do that for long.
Oh shit! I've got the YouTube open and I can hear myself. Oh god,
Yeah,
this
I
is
made
an
that
excellent
mistake
start.
yesterday.
All right.
What start? That's so indicative of HPA, starting off with a little bit of feedback and a little bumpy.
Exactly.
Let's do
No
this.
fire extinguishers though.
Yes,
So we're good.
fire extinguishers. All right, so let's begin with a bit of an introduction of both of ourselves, just to sort of kick things off and sort of give a bit of context as to why it's us and not some very self-important person over in the United States. You first, because you're amazing.
Oh, I was still trying to figure out who the self-important person you're talking about is. So,
Oh no, just unnamed for now.
hi everyone. I'm Ryan, formerly on the YouTube channel Make Test Battle. I haven't been doing that for a while, as you'll probably know. I have been working and doing other stuff, but HPA is pretty much every single mod I have done since I started it. So, yeah, don't know what else to say to that.
And I've been his competition for pretty much that entire time.
Oh, it's not competition. Okay, sorry. The lagged view of me that I'm like watching in this feed is actually super distracting, so I'm just going to minimize it. All right.
Yeah, I've only got the live chat open. I pretty much shut the YouTube window off immediately.
Yeah.
All right, we've got a bunch of stuff on both the Facebook feed and the YouTube comments that we want to talk about, and also a bunch of our own stuff I've got all strewn across my desk and bed beside me, so that we can, basically give a sense of how HPA is going in the world and basically make people feel less scared of the unknown. Because I think that's the main problem with HPA, if we're being honest, is that people don't know much about it. So we have to educate them so that they don't hate us and be scared of us for making amazing blasters with it.
There's also the problem of not knowing quite enough, which I think we'll have to talk on as well.
Yes, absolutely.
So yeah, if you monitor Facebook, I'll monitor the chat, and if questions come up, I'll jot them down in the old noggin. And yeah, because I think I don't know about you, I haven't prepared anything for this section.
No.
So yeah, it's pretty off the cuff, I think. I do have a blaster behind me that I've been working on that I'd like to talk about at some point. And I'm sure you do too, Liam. So yeah.
Yes. So let's start off with Leon's post here in Facebook. He's been working on a single shot, long shot with a cascading QEV system and a Specs BZ piloted by 1/8 QEV, which is piloted by a normally open toggle switch as the trigger. Designed and 3D printed a special breech and receiver so it doesn't blow it open. Interesting. So it looks like he's put a bit of work into this, and I think, in all honesty, he's gone a little bit overkill. What do you think?
I disagree. So piloting a QEV can be super important. So if people who are out there have used an XBZ or even a Specs BZ, you will know that if you slowly pull the trigger and you vent the air out of the quick exhaust, you can get vastly different performance. So when you pull the trigger, you want to pull it as quickly and as consistently as possible. So a way to get around that is by piloting it. My first thought was, you don't need to do that. But the other day, when I was using the ADHD that you designed at Bendigo, I was having huge inconsistencies if I like slowly squeeze the trigger. So it is a bit overkill because, it's a thing, but, not completely unwarranted, I would say.
So Andrew has asked, what's a QEV in the chat? And I know Atch is talking out of his wazoo here, but he's definitely asked a good question because he knows the answer. A QEV is a quick exhaust valve. And what it does is basically a diaphragm inside a housing that has an inlet and outlet and an exhaust. And the short version of it is when pressure goes into the QEV, it pushes the diaphragm forward and seals off your exhaust. Your air goes into your outlet. And then when you pull a normally open trigger or some sort of three-way two-position valve, it exhausts the pilot volume behind the inlet and basically allows all that outlet air to be redirected to exhaust.
So I have a great picture of this. And remember how we were planning? We're like, nah, we're never going to need to share screens and stuff. I have a great picture that actually illustrates how that whole idea works. And I'm just trying to find it and then maybe we can figure out how to do that, ? But yeah, effectively, what a quick exhaust valve does is it uses the stored air pressure to open the valve. That's the best way to think about it. So you have an inlet on one side that fills a cavity, and that pressure from both the inlet and the cavity hold the valve closed. And then when you remove the pressure from the inlet, that diaphragm is then pushed open by the cavity because it's no longer balanced on both sides. And then by using that pressure to open it, it opens very, very quickly, hence the name, and then all the air can flow where it needs to go.
So here's a Specs BZ for just to fill the example in. So your exhaust port in your XBZ is your muzzle, and your inlet port is here. Your outlet is actually all around it. So your diaphragm on your XBZ, if I can crack this one open, why did I tighten it too much yesterday? This is just great. Well, the outlet has a diaphragm basically at the back here, and that diaphragm, moves back and forwards. And when it moves forwards, it closes off the stem and allows all the air to travel around it. But there is a seal at the front stopping all that air from escaping out to start with.
Yeah. So that's what a quick exhaust valve is. And what Leon has been doing that we were sort of talking about before is he used a quick exhaust valve to fire a quick exhaust valve. So you stack them together, and then the first one that you fire can be ported quite slowly, and then the second one can be ported quite quickly.
Sorry, if you're watching my screen at all, Ryan, I'm I'm doing a bit of like diagrammatic representation with whatever I've got on my desk.
Now, I actually came up with a problem where I needed to port a QEV. It happens a lot if you have very, very big QEVs. So, some people are probably aware of the drain blaster. That is very similar to a Specs BZ, actually, in terms of the construction. It's just bigger.
Really big.
Yeah, but the air volume inside the chamber that feeds like the inlet sort of chamber is quite large. So in order to fire a drain blast, you need to get rid of a huge amount of air. And if you attach an MJV03, which is the standard, three-way two-position valve that we use, it doesn't actually have the flow rate to fire a drain blaster. So you could either use a bigger valve, or you could use a smaller quick exhaust valve to vent that, as we just discussed. And that's what I ended up doing. It was a bit of a shit post, but HPA drain blaster was pretty funny.
And it only needs to be done once to make the point, doesn't it?
Exactly. And I cannot find any of these pictures, which makes me sad.
So what else have we got here? We're probably going to be a little bit hard up on the Facebook feed. I've seen a few HPA posts come through, but not an awful lot. Most of them are flywheels and springs.
Question from Chris. Pretty straightforward. Do you see HPA becoming more and more commonplace, or likely to remain selectively niche? I'd like to see it more commonplace. I think that, just as I brought in lipos and proper motors into the flywheels, I feel like, storing energy in a spring is kind of the chump way of doing it. Storing energy in a compressed cylinder is the way. So we'll see. I mean, it's expensive, and in airsoft you don't see everyone using HPA, but it's definitely the best way of storing energy, in my opinion.
Yes, and as we, we're still pretty much in the formative years of HPA. We're only 3 or 4 years in, and by mass production standards, we're 3 years in, simply because the first Specs BZ V1s came out 3 years ago. And geez, time gets away. Now that we're getting into production grade of that kind of thing, it should become slightly more affordable than it was in the past. But we're working towards making sure that while we are trying to increase affordability, we don't want to be sacrificing quality in the process. Like, we could go for maximum affordability by trying to 3D print pneumatics, but that's a bad idea and it shouldn't be done.
Terrible idea. Now, do we know how to share screens and pictures and shit? I don't know.
Actually,
if I share my screen, no. If I share my screen, that will just change my camera, which should fill the thing. Hold on, let's try this.
Yes.
Although it might fuck everything up. I'm not going to do it.
If you've got your
Never
phone
mind.
nearby, you could pull it up on your phone and just jank
it's
it.
all good. I should have had a program in between my webcam and Zoom, but that's all right. What about a 2-3 electronic valve? All right, so there's a question that's come up about electronic valves, which the word you're looking for is solenoid. So a solenoid valve works in either two ways. The first, which is really bad, is if the solenoid directly actuates the valve stem. So you can imagine you're just replacing the mechanical input with a solenoid. The other way solenoids work is quite interesting. They actually tap off a little bit of the inlet pressure, like the one Liam's got. They tap off some of the inlet pressure, and then they have a small like plug that gets unplugged, and that being unplugged actually drives the button. They're good. What that allows you to do is control the blaster electrically. And I used to always use solenoids because you could put the trigger wherever you wanted. You could have as little like unused volume between the tank and the solenoid. My issue with solenoids, at least in my designs, is I haven't found one that's small enough to be better than the MJV03.
It's
that's
so
one
hard
thing.
to find.
Yeah, that's one thing I would really love to see would be, and Liam, maybe you want to take up this mantle, but like looking at making a Nerf-oriented two-way 3-pos or solenoid. I think if you did a balanced spool valve, you could do it.
Yeah, I have been talking with Fine Largeax from Reddit on this one. He and I have been back and forth for months because he actually works as a production assistant or an assembly line worker at at Mac Valves in the United States.
Yeah,
so
cool.
It's a very good contact to have. And once we've sorted out all the nitty gritties and I'm through all my prototyping stages with some of my current solenoid designs, we might be able to start working on prototyping for the sake of actually purpose building for Nerf. Because like you look at the paintball industry and some of their ridiculously tiny valves and you just go mind blown at the fact that something like no bigger than your finger or two fingers is piloting and cycling at rates unprecedented for our hobby.
Yeah. And what that really comes down to is actually designing something for purpose. Whereas in the pneumatics industry, their purpose is a pneumatic setup, which has no real space constraints in most circumstances. Where for us in Nerf, what you actually need is a fully holistically designed blaster that has the air tank, the solenoid, the firing mechanism, the driving circuitry, all of that all integrated. And so that's where it steps up from being like a hobby project to an actual, hey, this is a thing now.
Yeah. And I've pulled up a post from Colin Williams on Facebook because, talking about fire rates and, purpose designing stuff, I've seen this firing demonstration months ago, and I'm not sure how well Facebook's going to go with me trying to show these off, but it has basically the rate of fire of a Polar Star, and he's actually got a schematic here after long last. Yes. So here we go. Yeah. Okay. I recognize that schematic.
Yeah,
Do
exactly.
you recognize
balance spool valve. Yeah.
Yeah, and like that also looks very much like a very scaled up mag strike when you think about it.
Yeah, no, exactly. And the mag, I love the mag strike. I tried to replicate that 3 times and didn't quite do it properly enough. But the mag strike is a totally different beast, and it's actually very different to how people generally think it might work. But I can't quite tell from that. I don't think it is mag strike though.
It's close. There's a couple airlines underneath redirecting air to and from the piston by the looks of it.
Yeah, it's not high res enough for me. But for people who are curious, the Mag Strike and the Destiny are 2 fantastic blasters that are highly underappreciated that use a totally different operating principle to like a quick exhaust type thing, which makes them incredibly good for full auto designs and not much else.
On anecdote, actually, while I'm here, I accidentally a mag strike when I was prototyping Sobercore, because there was a point in time at which the stem seal wasn't properly seated, and thus not sealing on the inner bore of the bolt, and so it had a ridiculous, like, it would cycle without any input from me. Like, I just put the NJVO3 on it, and it just went. It sounded like a bloody machine gun going off. I had to actually hold the trigger down to stop it firing.
Yeah, but there's several designs like Atch has just mentioned the Boomco MA5, and that's another similar one. I did a video on MTB yonks ago on the Destiny. That one works quite differently, because instead of the air flow being redirected to unseat the membrane that we talked about in the quick exhaust valve, it's actually mechanically pulled off. So as the barrel on the mag strike pushes forward, it reaches a point where that membrane hits a stopper, and the thing keeps going, but the membrane is held back, and then it fires and returns and keeps doing that. It's quite clever. But yeah, I think the next step in the hobby is, how do you get a product that is a fully integrated, put air in and apply voltage to this to fire it?
Yeah. I mean, I'm currently working. You've seen my screenshots, and I posted them on not Airheads, on my Facebook pages and Instagram, of the work in progress I'm currently doing, which is using this solenoid underneath a supercore, to sort of like that in the shell to cycle, and with some extra work, it's going to be select fire, modular, all the bells and whistles of a Arduino system. But that's as far as I'm getting. Like, until we start getting into like custom valves, like you were saying, we're still going to be very much limited to the hardware that we have available to us already.
Yeah, and for me at least, when I do mods, I'm all about making the ergonomics of it first. And so for me, if something doesn't fit, or I can't get the tubes routed nicely or whatever, I don't keep going with the idea. It's kind of probably a bad way of doing things, and suggest people don't do it that way. But if I bought a whole bunch of different valves, and like one valve was like 5 mil too big in one dimension, and I just totally scrapped the entire design. And so getting that as small as, yeah, it was that Mac valve. Their 2.3 solenoid is fantastically small. Their 4.3 solenoid is fantastically small, but not fantastically small enough for what I was trying to do with it.
Yeah. And retrofitting something to a Recon is pretty much like the, I don't know, it seems to be the centric point of just about everything that people do. Like, you go just about anywhere in the hobby, and then you find yourself coming back to that very, very close to real steel profile of the Recon. And it's funny that seems to be, after so many years, it remains the center point of the hobby in just about all that we do.
Yeah. I mean, ultimately, and this is a bit of a tangent away from HPA. For me, I see a lot of people who make designs that look pretty or look cool. But for me, when I'm designing something, the actual functionality is the look. So I take a lot of inspiration from successful real steel. Apparently, I'm not a word to say, Alfa Romeo, but those rifles that exist in real life are ergonomic masterpieces, and getting that part of a blast is the most important part. And that's why I think the Recon is an unbridled success and will be continually copied forever, because it has everything in the right place.
Yeah, and that's just it. Like, we've basically got two ways that we can move in terms of like air pressure blasters in the hobby, and that's sort of migrating towards paintball tech and paintball designs, or migrating, towards the airsoft side of things with like the real steel shapes and formats, and building around those two constraints. Like, no blaster better demonstrates the paintball side at the moment than ADHD.
Yeah, exactly. Like, that's and that's just the thing. When you take what a blaster needs to be, boil it down to its purest elements, filter out all the fluff, that's what you get. And that's why paintball is that, because paintball doesn't need to be anything else. Airsoft has its sprinkling of it needs to look like a real steel rifle to appeal to the airsoft crowd. But at the end of the day, a blaster needs to have something to hold it, something to brace it against your shoulder, something to hold the magazine, something to release the magazine, something to contain the mechanisms. That's it, you know? Yeah.
Actually, on that, why don't you show off your blaster now?
Oh, yeah. So I posted a couple of pictures on the Discord, but this is what I've come up with. Well, it folds open like a aforementioned thing, and unfortunately, this little Picatinny rail here is slightly too long, so I wanted to belt sander it, as we talked about before. But yeah, it doesn't quite close up due to a error. But basically, what I've done with this, and the reason why it does look like exactly what we talked about, is I wanted to take as many off-the-shelf components as physically possible and put them into a design that has as few 3D printed parts as possible. Because for me, if you are 3D printing something, it's because it's a prototype piece. It's not an actual thing. That's my personal opinion. Don't have to agree with it. But I'd rather have an off-the-shelf barrel shroud that you hold on to, handguard, forend, whatever you want to call it, than print one. But yeah, so that's a collection of a lot of airsoft parts. It's using the Supercore and some real steel parts, and it's neat because it has all you need to do. It has a place to hold it. It has a place to put the magazine in. The biggest thing for me, no screws that you actually ever have to touch. So that's something I'm actually pretty proud of. I'm using these things called, I believe they're called cotter pins. People should get around these. They're little pins with a ball bearing that's spring loaded, and you just press them in and they stay in, and then you can push them back out. Everyone who makes 3D printed blasters use these things. I think they use them in the Dart Zone Pro thingy.
Yeah, the Dart Zone Pro and the Jet Blaster Cedar both do cotter pins, though they go all the way through. So whether or not you want to design a recession inside your blaster for retaining sections and you have two cotter pins, or whether you just want to go the one through, there's multiple different ways of doing it.
Yeah, for sure. That's how I sort of think about it. I mean, do it however you want to do it, but that's my perspective of it, and that does come from working in the industry. That's kind of like my job now. So thinking about designs in that way, it's just a different way of doing it.
Yeah.
Anyway, side rant aside.
That's right. Another build we've got here from Atch, an HPA bullpup rifle that he has built many, many months ago, and that had to be in portrait mode, didn't it? He's got a Supercore in the back with a solenoid underneath, and he's really kept the pneumatics so compact in there. Like, that stock is pretty much all pneumatics and nothing else. And he's got a clamshell design by the looks of it, and it works beautifully from what I've seen. I've seen some of the gameplay of this rifle, and it's just so crisp. It's so great to watch. And it was one of the first HPA printed blasters that I'd seen in the wild, even while I was designing ADHD. So it was really good to see, just given just a model of the Supercore, what people were already doing with it. And it's beautiful because, like we were saying, you take away the limitations of manual prime pretty much, and all the limitations of all those linkages, boil it down to just what you need, and you start seeing some really fun, comfortable, fundamentally sound builds.
Yeah, I think that's why people got around like flywheels as well, because once you do away with all the other bits and you just have a cage and something to push darts into it, you can make it whatever you want it to be. And that's quite liberating, I think, for people who are creating those sorts of things. And that's, the other part about HPA, like you have a tank and something to operate it, done.
Yeah. I mean, you look at the tiny minimal profile of ADHD. There's nothing there. Like, that's Strife profile. That's it. I mean, you've got big ass stock, but that's my own personal preference. And barrels.
Yeah, exactly.
Barrels.
Yeah. Actually, that's what I was. Yeah, We'll talk offline about that. So let's talk about a few things that come into actually designing a HPA blaster, because some people might not know about the things that you need to consider.
Yes.
So the first thing with HPA, and it's going to sound stupidly obvious, is you need to get the high pressure air into your tank at low pressure. And there's several different parts to that. So the first thing you need to consider is how you actually get the air from high pressure air to something usable, because an air blaster is not HPA. You can have a 4B or a B-bum or whatever throwback showing my age words you want to use, but that's not HPA. That's just an air blaster. So the first part is the regulation, right? And this is something that I'm going to let you talk about because I haven't updated my reg in a very long time. So do you want to run us through what options exist for taking a paintball tank to usable pressure?
Yes, and unfortunately, it seems that I've left my bottle rig downstairs at the moment, so I can't actually talk much about the bottle off options as I would have liked to. But there are, in the industry now, at least, there's sort of 4 options that you can go with. There's the old style stuff that you haven't updated your reg, but it will still hold its own in today's meta. That style of regulator is either the Wilkerson or the Norgren regs, and those are both beautiful. But the caveat with those is that they require an SLP tank to operate. And so, with your first stage regulator, when you're using a bottle off system that uses a Norgren or a Wilkerson, you've still got to be using SLP. We've done a bunch of digging amidst the systems, evolution since then, and basically 2 regulators now stand out on the market as the market has evolved for paintball and airsoft for bottle off rigs, and that is the Wolverine Storm, which I would love to show off but is integrated into my Recon, and the Polar Star MR regulator.
So just splitting that up into 2 parts, there is sort of 2 ways of doing the regulation. You have your paintball tank, and that's sitting when it's full, either at 3,000 or 4,500 psi. And most blasters will want air somewhere between 40 to 80 psi if you've done a reasonable design.
Yes.
So
and this no, you first. Sorry.
Yeah, sorry. So you can either take there's either a 2-stage or a 1-stage approach to regulating that pressure. The first way you can do it, and the way that my build is set up, is you take that 3,000 psi and take it down to something usable is as an interim step. So I have a regulator that outputs 300 psi from my actual paintball tank. And then you take a second regulator that can take 300 psi and convert that down to 40 to 80 or 150, I think, is the max output on mine. Yes. The other option is you have a regulator that can take 3,000 or up to 3,000 psi and bring that down to your 40 to 80. So that's sort of where the distinction sort of is. So the Wolverine Storm and the Polar Star, they're a 1-stage setup.
No, they're still second stage.
Are they?
Yeah, but what I was going to say is that with the advent of finding these regulators, they're actually designed to take the standard output of 800 psi.
Oh, they take 800.
Yes.
Gotcha.
Sorry, I didn't specify that before. And this actually brings into a question from the YouTube chat. Unless we already talked about it, can we go over the differences between HPA and LPA? I've never been able to figure out what the difference is. At the blaster level, there is no difference. You can, theoretically, you can sit there with a hand pump and you can pump up ADHD. You could mount the pump here if you really wanted to. You could hand pump ADHD till, you got your 40 to 80 psi or whatever you wanted to run, and your breech would fill up, and you pull your trigger, you hand pump, and you go again. Oh, I shouldn't be doing that on camera because, well, let's see what YouTube likes to do. But when you get into LPA is basically just using a compressor to achieve the same thing, or a low pressure reservoir tank to achieve the same pressures. And then HPA is just using the same bottle to regulate down.
Right. In other words, the way I would put it is you have an air blaster. The ADHD is an air blaster. That thing behind me, it's an air blaster. It uses an air tank. And then the HPA part of it is the actual air storage. So storing the air somewhere else, or not inside the air blaster's tank, and then feeding that in sort of like a master tank, slave tank sort of setup. That is where it becomes a HPA. Now, some people say LPA because you have a storage tank at lower pressure, and you can do that. You could store it at, I think, 150 psi is where people sort of draw the line. But something like a mag strike, you could call that an LPA blaster because you have air storage that is at a low pressure that then feeds into the actual air blaster itself.
Mm-hmm.
That's probably another way. And you can have a HPA mag strike by taking off that LPA tank and putting in a higher pressure tank. So that's, if I was to answer that question, what LPA and HPA, it's just the pressure that you're storing your storage air at.
Yes.
To feed into an air blaster.
Pretty much all air blasters in Nerf operate between 0 to 150 FPS. So there's no intrinsic need to try and use 300 feet or 300 psi or 800 psi or 4500 psi.
Yeah. I mean, you could. I'd be really interested to see what a blaster, because that's what paintball do. They use 800, and it's an interesting reason why they use 800. But yeah, so paintballs run at 800 psi, so they need less volume to get the same amount of energy storage per shot. But maybe that would just Shrek darts. So who knows?
Yeah, I mean, you're getting into pressures that can be generated from combustion at that point anyway. So you're getting crazy. You'd at least be breaking darts, if nothing else.
Yeah. So just having a look, is HPA dangerous to have bottle integrated into the blaster itself? Is dropping the blaster a worry? So there's two parts to that. That's the first thing to remember, like in the context of thinking about the answer to that question, is that all of these things are designed for paintball. So they're already designed to do what people who play paintball do with them. So I don't think it's an issue because they're designed to already get struck by paintballs. And also think about it, if you have a pressurized tank, the force wants to go outwards. So putting force downwards on it is just relieving the force that it's already containing. So.
And when it comes to Nerf in that sense, it becomes more of an issue, not of the parts that you're using for the HPA, it's how you're integrating them. For example, here is the aforementioned Recon with an Ascension adapter and the Wolverine Storm regulator integrated in. I have complete faith in the Wolverine Storm as far as the regulator goes. I won't need to worry about that ever. However, if I were to drop the blaster, I'd be putting all of the impact force on 4 screws, basically, if the tank were to jam up inside there, and that would likely be damaging the print. So when you're designing blasters for HPA, you at least need to be thinking about, and Ryan demonstrated this beautifully with printing ADHD and doing a stress test of it at Wasteland.
It broke, by the way.
Yeah, I expected as much. It becomes the responsibility of the designer to be making parts, be it accessories or full blasters, that are able to withstand HPA. The ADHD, very still much a work in progress, in spite of the fact that the files are on Thingiverse, because I'm constantly getting feedback for it. I do want to improve it to be a strong, rigid, wasteland-proof blaster. And like the one thing that I actually don't have to worry about in my design as far as bottle on goes is the bottle on mount. There's so much plastic here, and the screws that are holding it in are secured on the inside by a metal bracket attached to the Empire regulator that just makes the entire section so rigid. So I could abuse the ever-loving crap out of this and the rest of it will die before this mounting part. If it's well designed, it will hold.
Yeah. Now, in terms of the actual, so once you've got your air down from, so air tanks are either, I keep saying 3,000 or 4,500. That's just the standards for air tanks. You could be using whatever pressure in your tank, but I'll use 3,000 for simplicity. So once you've got it down from that to your actual blaster's pressure, you need to get it safely into somewhere and then release it on demand. And this is somewhere where you see a lot of people who know just enough to get themselves hurt. And this is like where you sort of have to put the safety hat on, and where, you know, you need to take a step back and really think about air pressure, right? The amount of energy that is stored in a paintball bottle, or even just like an XBZ when it's pressurized, is a lot. The last time I ran the last time I ran the numbers, the amount of energy stored in a small paintball bottle is like 150 rounds of 308. Like, it's a lot. So
that's all at once if it fails.
Exactly. So you have to understand just what those forces are and what they're capable of. So the first thing to consider is, you know, if something fucks up and you get full storage pressure through your blaster, what fails first? So you always want to be considering, you know, what's going to break. You know, back in the day, people used to make air tanks out of PVC, and that's terrible because the failure mode for PVC, it shatters and it sends splinters everywhere. You've seen people potentially, I think someone posted a 3D printed air tank that was basically a 3D printed copy of a Spectre BC, which I think is cool. Like, congratulations for not killing yourself doing that. But the problem with that is that the actual margin of safety that you have on that is going to be very unpredictable. It's not that it's not high, it's just that it's unpredictable. You know, you could do a pressure test on a 3D printed air tank and find, hey, it comes out and it survives 500 psi, so you're happy to use it at 100. But what if your printer misbehaves one day and you get a void? What if someone takes your design, prints it at 10% infill, and it blows up in their hand? You know, that's why when you are working with these things, you need to have that constant idea of the margin of safety. If you've tested something at 50 psi, you should only ever use it at 10. It's
called factor of safety, and it's built into engineering. If you're not willing to put your blaster up to a certain pressure to actually use it in a game, then you shouldn't be even thinking about it. Like, there's a couple things going on in the YouTube chat at the moment about soft drink bottles, and Airzone blasters earlier this week released a 3D printed supercore, which was an April Fool's joke because he had actually hidden a Flywheel the World solenoid inside. It was bloody brilliant because I was in on that joke, so I stayed really quiet. And it was amusing to watch people take it seriously because it really highlighted the fact that there are people out there that don't know, and that's why we're here to do this. That's why we need to educate so that these mistakes don't get made, or if they're done in a way that is a safely tested manner, then it can at least be recorded for posterity. Things like printed XBZs are not an end goal. You don't want to use it. And whoever keeps suggesting soda drink bottles, they're an entirely different can of worms.
Yeah, see, I have no problem with soft drink bottles, and this is going to be slightly controversial because the testable failure point of a, you know, commercial soft drink bottle is about 250 psi. So if you want to use that in an LPA setup where you're pumping it up to 100 psi, that's fine. That fits in my happy margin of safety. What's not fine is PVC, because that is, I believe they proof those to 150 psi, and then
that's
when they
pressure.
do go, but pressure is pressure. But the problem is the energy that's stored. So if you have a soft drink bottle and it breaks because it's full of Coke and the CO2 is expanded and it pops, the actual energy that's stored in that is minimal. If you do the same thing with a water pipe and you get water leaking out, the energy is minimal because it's not compressed, it's just under pressure. You put air in it, different story. PVC, you get fragments sent everywhere. But I'm okay with soft drink bottles because when they fail, you get a tear, and they They
that's
don't
because of the material used.
frag. Yeah. So yeah, wrapping a soft drink bottle in fiberglass and pumping that up to 100 psi. Yeah, go for it. It's dumb. Like, there's better options. Your time is better spent like working at your job and buying $100, 3,000 psi like aluminium airsoft, setup. But you can do it, in my opinion.
By the amount of time you put in, you're better off just buying a small HPA bottle. It's wasted time versus wasted money.
Yeah.
And as everyone knows, time is money.
Now, this is a good question that Aldos has just asked. As an event organizer, not knowing much about HPA, is there any way for me to easily know if the blaster someone brings is designed/used responsibly? That's a really good question. And my counter statement to that question is, as an event organizer, it's your responsibility to be aware of that. That would be my point. So if you're an event organizer, you need to be the filter. You need to be the catch. That's sort of my statement there. So, but the first thing to check is someone using pneumatics parts. Is everything they're made, some sort of machined. I'm not going to say if it's out of metal, it's safe, but it's because you can't, as an admin, you can't, do a hydro test on someone's design. But yeah,
it is a good question. It is a very good question, and as I guess my own input on that, as as another event organizer as well, is that you have to. I mean, you sort of have to be the smartest person in the room, to some extent. You don't have to know everything, but you do have to know at least enough that if you were to use the blaster, you wouldn't hurt yourself. That's how I see it, is that if you don't understand the blaster well enough, then it's someone else, could pick it up, as people do. It doesn't even have to be the specific person that intends to use it all day. Someone else could pick it up, go, hey, what's this do? And self-destruct because something was not where it should have been. And that's a very real concern, especially within, groups with young kids around. HPA has been used in wars with young kids to varying degrees of success. I used it
at HVC. I used it with my Destiny at 60 feet per second darts, like 14 rounds a second full auto, and it's safe. So
yeah. But on a counterpoint, I actually have played at a war where I've seen a blaster fail, and that was about 4 or 5 years ago. Basically, just after I got into doing HPA regularly, someone decided it was a good idea to connect a CO2 bulb directly to a plastic garden hose and then attach a barrel to it, because Ipswich. And when you get
like a trigger thing.
Yeah, a literal garden hose trigger valve. Nice. He stuck a barrel on it. He got 6 shots in first round. 2 of us were using HPA. Kaboom. Both of us looked at each other and went, "You're not dead. You're not dead. What happened?" And then there's this poor kid that was using this garden hose, crouched over, holding his privates, because that was the first thing he went for when the thing sagged, and just First problem was it was unregulated CO2. Second problem was he didn't know what he was doing. Both of us that were using HPA at the time said, that's not safe. You shouldn't use that. He went, nah, it'll be fine. We said, on your head be it, and it almost ended up on his nads.
Yeah. So one thing people have brought up in the YouTube chat is tournament locks. That's a complete non-issue and should not even come into the conversation. It doesn't matter what pressure you run it at. It's whether the design is safe. The issue of a tournament lock is to stop people having higher pressure for higher FPS. The issue we're talking about is having a system that will explode and hurt you.
To answer Nicholas's
tournament lock is not the question, not the answer to this question.
To answer Nicholas's question, the CO2 didn't fail because the bulb did exactly what it was rated to do. He was pushing unregulated air up and into a plastic valve. You do the math.
Yeah, so CO2 will come out about 800 psi, and a water hose has usually like 5 psi of head. I don't actually know. Yeah, it's not designed for it.
Yeah.
Someone's asked about CO2 canisters. I think CO2 canisters are interesting, but a dead end. James Zhu at Melbourne Nerf Wars had what was that, like 4-shot crossbow thing? He had a CO2 canister in that, and it was like one of those smart AR things, so you could like fire it 4 times, and that's kind of cool. But you get so little capacity, and they cost so much money that it's a dead end.
And here's a post from Facebook actually that Ansuz Alges, I hope I didn't butcher that name, has posted, and he's got a 3D printed rifle that he's done a CO2 build with. He's using 2 stages of regulator here. He's got the CO2, the Wolverine Wraith regulator into the Wolverine Storm. So the Wolverine Wraith acts as a stabilizer for the air, and then the Storm does the rest of the regulation, and it's just a standard Specs BZ rig otherwise. So he's made it safe for CO2 consumption, but he also said that he can only really get 10 shots out of a tank. So he's made it a single shot bolt action.
Yeah, and it's that capacity that to me just says like complete dead end. It's and the trouble with CO2 bulbs is you can't refill them unless you actually create a faux like paintball tank by like putting on some adapter that exists. I don't know. You're just paying so much money. Like James Zhu, again, he was all about the CO2. He did a soda stream sort of setup, and it was like cool, but it costs you like $20 to fill your tank, and you only get 100 or so shots. Like just economically,
there we go.
He said,
Ansuzal just has timed in on the chat. He's 10 shots at 140 psi should get 30 to 40 shots at a normal 40 to 50 psi. There we go. That's still, like, when you think about it in terms of mags, like think about it in terms of mags for a second. Katanas and Talons both have 15 dart capacity. You've got 3 mags there. That's it.
Yeah. It's different levels of acceptability hit different points, but if you run the numbers on it, if you're paying about $1 for those CO2 bulbs last I checked, if you buy them in bulk, that's 50 cents a magazine versus a paintball tank, which might cost a couple hundred to get it originally, but my tank goes through about 3,000 shots. So, even if I didn't refill it, it's still a same order of magnitude as CO2. So,
and then you take into a consideration that, like paintball, like let's just jump onto paintball for a second. They've moved from CO2 to HPA pretty much exclusively as time's gone on, and their designs are getting more efficient every year. But when you factor in only the cost of the ammunition, and in this case, your CO2 becomes ammunition because it becomes how many shots you get per use. You are going like 10 cents a paintball, and then you, like Chris has just posted in the chat, 20 cents a shot for things. So you're actually already paying more than you would be for paintball for the almost relatively exactly the same performance.
Yeah. And the last point, not to beat a dead horse here, if you're doing a design for the compactness of using a CO2 bulb, that's fine. But if you have a bottle on your back and you just connect a remote line to it, that's even more compact because you don't actually have to carry the bulb. There is a question that is quite a good one that's come up on a similar vein. How do you fill tanks?
Yes.
That's a good question. There's two kind of options. The one that we went with at Melbourne Nerf Wars, play at a paintball field or be near one, and they generally will just fill it for you. Do you want to talk about the other one?
Yes, home compressors. Home compressors are great. The problem is they're expensive. So there's multiple ways to do this. There's actually, as far as I understand, 3 ways to fill a tank from home. The first is a hand pump. You can get this for about $90 Australian. Blaster Tech, please confirm or deny. And it's a manual pump. It gets you up to 3,000 psi, and then with my body weight of 65 kilograms, Don't ask me for the poundage. I'm not American. You basically have to put all your body weight onto that pump to actually get the pump to go anywhere past 3,000 psi.
And they get really hot.
Yeah, you have to actually stop every 5 minutes to let it cool down. It gets that hot. It's
and
too
also
hot
take
to
a
touch.
breather.
Yep. Aldos can't go to gyms in the US, so manual pump away.
True. Like, lockdown mode, it's probably a good option.
It's arm day, it's leg day, it's everything day. Let's go. Second, shoebox compressors. This is a booster. It's actually a booster compressor for your first stage compressor. So as a prerequisite, if you have a shop compressor that is capable of putting out regulated air from 150 psi down to say 100 psi, then you've actually got something that you can boost. And this is time consuming as well. Not quite as time consuming as a manual pump, but it is still time consuming. It acts as a booster of your input air and boosts about 85 to 100 psi through a second stage of pumps and boosts it all the way up to 4,500 with a mechanical cutoff. It's crazy because it was like revolutionary years and years ago when PCP tanks were first coming in. Unfortunately, now the cost of getting a shoebox is actually more than buying option 3, which is 4,500 psi compressors from eBay. I bought one recently because I wanted to replace my shoebox and actually, be a tester for this. And I know Alistair from Wasteland, I know Ken from Sydney, I know Andrew from Brisbane all also have them. And I know Nikki, I think, was the first person to show me one. And it's a bit of a lottery with, China. China is hit and miss with either electrics or mechanics. So far, I've heard no faults at all of the mechanics of these things. Everyone that I've talked to has at least put their correct hydraulic oil into the compressor so that it's cycled properly on the way through. But Nikki actually took one apart. She's Spirit. She designed the Spirit breach. She took apart the compressor to check the electronics and found out that there wasn't a ground wire.
Yeah. So, yeah, that's no good.
The whole thing was live.
Yeah. Actually, we've had some stuff at work. We got a couple of various bits and bobs that were just grounded onto the casing, which, while it works electrically, it doesn't work when playing safe with humans. So, yeah. Either way, don't get a PCP pump. These shoebox compressors, are probably the safest option because they're mechanical systems, but the 4,500 pumps that you can get are probably the best way. And I would suggest if you have a group, everyone who is thinking of going HPA, just pitch in and then, leave it at someone's house, fill everyone's bottles before the war, and then go from there. Which is why I would suggest when it comes to actually picking your tank, get a big one so you don't have to fill it often.
Yeah. And this is a matter of personal preference, and I'm finding pretty much the same thing as I work with, ADHD, Super Recon, and whatever. You can buy, your bottles. You can buy your 3,000 psi, 13 cubic inches. The thing is that your shot count for those, for a Spec B0 Supercore, you're only going to get about 200 shots out before you need to refill them. And if you've taken, this and a hand pump to a war, then it means you're going to be spending time off field, which is not ideal if you're not at a paintball field. But when you're playing games like Ion Rush, like our group do, there is a bit of downtime between games, so that's acceptable. But if you've got the ability to do something like bottle on with HPA, such as ADHD, or if you want to run a remote line, then yes, having a bigger bottle is actually better. You will make back your, discomfort of having something slightly heavier with shot count. You'll be able to sit back. You'll be able to work more defensively. You won't need to be as aggressive because HPA has that range advantage over a lot of its competitors and its accuracy advantage over springers. Yeah, I said it. But it's mostly just a matter of actually having the shots there to use that is the most important thing when you're working with these blasters.
Yeah. And like personally, I go through 2,000 rounds in a round even at Wasteland Wars, so having to then spend an hour pumping up my tiny little tank again, it doesn't make sense. If you're at a paintball field and they have a huge tank that you can just plug in and refill, it makes total sense to do that. But if you're not,
yeah, so TK Jones has said, when a round can last an hour and a half, then a big bottle is the only choice. Yes, and with the boys that play those large scale tactics, yeah, absolutely. Go for a 68, go for a 90. Like, those bottles are designed to just go and go and go.
Yeah. Okay, I'm just going to scan the chat for if there's any questions. What? Hold on. Oh, okay. We got one last thing to talk about, and this is kind of the final part, and this is more air blaster stuff. Once you've actually got the air into your tank in a HPZ, you need to get it out the end. And this is a question that comes up all the time. What's the optimal barrel length? What size tank do I need to use? What pressure do I need to use? Blah, 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 blah. And they're all sort of the question of what is the interior ballistics of a Nerf dart? We don't know. we don't know.
Bradley and I discussed this slightly yesterday, but we basically came up with the solution of there are too many variables.
Yeah, and there's a tool that exists. If you want to look it up, it's called Light Gas Gun Tool, or Gas Gun Design Tool. Sorry,
GGDT for short.
Yeah, Gas Gun Design Tool. It comes up with an answer. Is it right? No one knows. The best way to do it is to just take a barrel, trim it down, and that's your optimal. The other option is take a barrel that you think is the right length for your design and looks cool, and then just change the pressure until you get the FPS you want.
And then add a scar barrel.
Yeah. The one thing you want to make sure not to do, one of the big differences between a Springer and a air blaster is the shape of the pressure, like your chamber pressure, effectively, if you're familiar with firearms. With a Springer, as the plunger closes, the pressure ramps up, and then it ramps down as the volume increases as the dart moves out. With an air blaster, your pressure almost instantly spikes at the flow rate into your barrel. So you need to be much more aware that if you have with like zero dead space between where you're storing your air and your dart, when you open that tank, your dart gets exposed to the maximum pressure inside your tank almost immediately.
Mm-hmm.
And so one of the counterintuitive things in air blaster design is you actually want dead space in order to slow that down. Or you want a flow constriction to reduce that pressure spike, because otherwise you just blow the heads off darts every single time.
This is where the Specs BZ has actually done this without me meaning to quite well, in that, like, combining the Specs BZ design with, what we know already, the internal stem actually has some dead space already in it. So you can have like zero dead space with your dart sitting back here, but it's not going to hurt the dart as badly as a standard XBZ did, like Ryan would, be able to attest to, with using just straight off the muzzle, that burst pressure straight away hits the back of the dart. It doesn't happen in this. It does get a chance to ramp up.
Yeah, exactly. So that's one thing definitely to be aware. I mean, that's more just air blasters in general, but at this point, a lot of people group air blasters into HPA, because why bother making air blaster and not HPA it, I guess.
The technology exists, so why not?
Exactly. Yeah, delta P pop dots. Yeah, exactly. So it's all about reducing that pressure, and it's really interesting. That's the same thing you need to do with firearms. Picking your powder so that your burn rate is low enough that your pressure doesn't spike to 100,000 psi is important.
And you know much more about that because you've actually done a lot of research into this now as part of your job.
And anyone who is into firearms or reloading or anything like that, it's exactly the same conundrum. If you use a powder that is too fast, like if you use a pistol powder in a rifle, you get really bad things happening because that pressure spikes too quickly. And it's the same as, the HPA just has the ability to deliver a much higher pressure to the dart, even if the effective energy is the same. Yeah.
Okay, so we've got one on-topic comment related to this currently.
My goodness.
He said, Redneck Nerf on Reddit experimented with combustion-powered Nerf. I would expect nothing less from a man named Redneck Nerf. And then we've got 2 questions. Really good start. How difficult is it to build a semi-auto HPA blaster, and are there any written guides anywhere? We'll get that. Second question is, what are your ideas for what we can build with HPA that we haven't done so far? There is a post on Facebook I want to talk about after we deal with question 1. So, how difficult is it to build a semi-auto HPA
that was question
blaster?
0. That was question 0. Semi-autos. So with your supercore, it's stupid easy. With anything else, you may as well go full auto. There's sort of 2 pathways that you can go about this. You can have a air tank that does the semi-auto thing, and that would be the supercore. Then the other option is having some mechanism that does something that makes it semi-auto. And if you're doing that, you may as well just throw a little Arduino in and do that. Or if it's pump action, then it's actually easy. Oh, that's something to talk about. Yeah, do you want to talk about the supercore, and then I'll talk about the long shot bolt sled way that I do?
Yes. Okay, so right, like Ryan was saying, semi-auto HPA nowadays is stupid easy, and this is basically the dummy prototype of V3.2 because I've still got a bunch of reworks to go. Even this one doesn't fully work yet. This is just basically mocked up for the sake of this showcase. This is all that's required as far as the back end goes for a supercore. What you're not seeing is the receiver and the barrel. That's it. All you've got is 1 inlet hose, 1 MJV03, 1 outlet hose, 1 supercore. That's it. That's it.
Now, the way that we did, so I don't know if people count pump action as semi-auto, but it's close. Another thing you could do, for example, you can fit an XBZ inside a long shot plunger tube, or you can rig it up in such a way that it fits. So what we did is we took artifact like pusher style bolt sleds, glued it to the end of an XBZ, and then just had that in the shell, and the air tank moved back and forward, and then you pump it and get that sort of going that way. Is that semi-auto? I don't know. You could connect that to a piston. I did. Oh, actually,
Blaster Tech actually has such a long shot.
That's where I blew up an air tank. That was fun. Yeah. So I had a long strike that I had in a very similar way. So I had a pusher breech that had a XBZ connected to it, and I had a tiny little piston that would push the breech back and forward. It was connected to an Arduino. It was really cool. The first, I tested it at home. It worked great. It was sort of like 5 darts per second full auto. And then I took it outside, and instead of my 50 PSI test air, I connected it to 60 PSI out of my paintball tank. And there was a small hairline fracture in the XBZ, and it blew up. Scared the shit out of me, confused everyone else, and I had no blasters left for the day. So I was very sad.
So I've just pulled up Dean's Blaster Tech's semi-auto long shot. Very similar to what you've said, except he's using a brass breech. He's got a brass breech and a Specs BZ in the back, and he's just cycling it. I'm honestly scared of that thing on an Iron Rush field. He's tuned it in to perfection. It's great to watch. It's terrifying to play against. And as with all of Blaster Tech's blasters, it never fails.
I would say on that, people look at full auto and go, this is clearly the next step that we need. We need to do HPA full auto. And I completely disagree.
I actually agree with Ryan on this one.
I think that semi-automatic, even pump action for HPA is fine. I think full auto is useful in something like a Strife or a Rapid Strike, where you can put out a whole bunch of darts and just sort of hose down an area. But when you're making a design that is more about accuracy and long range, it doesn't need to be full auto. It can be. It's fine, but doesn't need to. What was I going to say? I was going to say something about... What were those 3 questions you asked before?
The second question.
Yeah, what was the second one?
What are your ideas for what we can build with HPA that we haven't done so far?
That was the third question.
Okay, well, there's the first. The first question I think you were thinking of was the combustion powder one.
Anyway,
this one,
something it'll come back in my mind.
I want to show this off before we're done, because this is a very good answer to that question from Atch, because Atch wants it to get shown off.
Yeah, nice.
So he's designed here an HPA grenade launcher using rockets, pool noodle rockets.
Yeah.
And so I want to ask you, because I know you've worked with Reese. Didn't Reese used to use rockets back at or the old Melbourne Nerf Wars?
That was yeah. I will say that this is a cool use of HPA though, because traditionally, if you have something like an XBZ firing demo rockets or a demo firing demo rockets, you don't have that multi-shot capacity. I've started doing CAD on something like this like 3 times now, and I'm glad that someone's actually gone and done it, because the closest thing that I can think of to this
Jamie Heinemann.
Okay. No. So Chew, he used to Outback Nerf used to come to HVZ, and he had a triple shot, and as a joke, he mounted 4 basically demo barrels to it, and so it was a pump action demo triple shot, and that was hilarious. But this
would have been awesome for shield rounds.
Yeah, it was good fun.
Oh, that was I want to give a big shout out to Atch for really pushing, the envelope on this one, because we don't really have an awful lot of untested things in this hobby that really changes, the perspective like this does. Like, this has opened my eyes to, oh yeah, that's right. Specs BZs are just XBZs, and XBZs used to fire rockets. So it's just we've come full circle, but in the best way possible.
Yeah. I think in terms of where HPA could go, I still think that the MJV03 needs we need a solenoid that is that convenient. I don't think there's one that exists, and the only ones that I found, which are those Mac ones, they're like $100 a pop. They're insanely expensive.
Yes.
But if we can get that makes more designs possible. And then it comes to the creativity of people, doing what people do, where you make just different layouts. Some people like bullpup, some people like things that look like paintball, some people like whatever, just creativity. I mean,
like one thing that
and no clamshells, people. You hear me?
Yes.
Get rid of clamshells and stop using printed pistol grips. Just buy a Magpul, K2. Just use that. It's the most comfortable thing you have ever held. My goodness. Actually, someone should make a 3D model of a K2 so that you can just add that into your thing, because that's just the perfect grip angle, perfect grip shape. Anyway, rant over.
So one thing that a lot of people talk about all the time, and I guess I sort of actually disagree with, is HPA sidearms. So this is a pigeon. This is the Desert Pigeon by Mr. Heath Pants. You guys already know it. I don't need to tell you everything about it. This is the reason we don't need HPA pistols. This is great. It does exactly what it says it does, or, it's a semi-auto pistol. Like, you don't need to try and replicate this to do exactly the same thing as this. I mean, your only benefit if you're doing something like this is the noise output. You don't get crazy noise from these as is, but you will still be quieter with, a CO2 pistol or a, like, I know Martin Naroda, he's designed a couple of CO2 pistol designs, and he's, working through the prototyping stages of them. And I applaud him for it. They are beautiful designs, and he's putting a lot of thought into them as he goes. Is it absolutely necessary? I don't think it's absolutely necessary, but it is good to see that thought process go into it. And it is, it would be great to see something come of it, but I don't think that's necessary for the progress of the hobby.
I agree. I think that, the advantage of using HPA, like when we say HPA, we mean a stored tank of pressured air regulated down. That system is the most useful when it comes to rapidly recharging a high-powered air blaster, and it's not as useful for a secondary. The other thing is, if, like, the complete flip side is the Destiny question. If someone can make a design for a Destiny system that is mag-fed, that's fantastic. That's what I would love to see, if someone could do that. Because, sometimes you want 14 darts a second and you don't want 300 feet per second. But so, usually, yeah.
Yeah, we've got another question here. Heatwave has asked, could you use HPA in a shell ejecting blaster to make it semi-auto?
Sure.
I mean, I think I've talked to Atch about this at some degree of length, and I've just said to him, all you need to do is change over the pusher. Like, change over the tip of the supercore to use a different pusher. That thread in there is M14 by 1.5 because it was a die thread that I had on hand. It's not a standard thread, but it does fit, and you only really need to design around one thread and change it out for a printed pusher, and you're set to go. That's all it takes.
And it's one of those questions that's kind of a bit pointless. It's like, sure, you could do it. Why couldn't you do it? The HPA doesn't, like, make or break that idea. Like, the question there is, can I build an air blaster that is shell ejecting? Sure. And that's something that can be done.
HPA just opens out the possibilities of what can be done. And like, a lot of my prototypes have been trying to replicate the function of the blaster that they were built in. The Power Strike 48 up on the wall over there has a giant godforsaken galvanized steel tank hanging out the side, but it doesn't use the pump action, but it still has that semi-auto capability feeding through tubes. So in my mind, that's still a success, even if I had to sacrifice one of its functions. The barrel brake, I love that thing. I swear by it. It was my favorite blaster for a long time because it just put in and worked. It's a brake action HPA XBZ. It works, no problems. HPA makes these things possible. Do we need them? I mean, no, but do we need anything in the hobby?
Yeah.
We do things because
exactly.
It's fun.
Like, you could take that barrel brake and connect it to a pump and it would still function.
Mm-hmm.
But it functions far better as an effective blaster if you're automatically refilling it instead of having to pump it. So
that's basically it, isn't it? Like, your HPA just takes air blasters and makes them repeatable.
Yeah, and that's sort of the two, like, where it actually, the repetition helps. I don't think it helps in a sidearm like grade blaster unless you're talking something insanely fast rate of fire like the Destiny, because you can kind of achieve that with a rapid strike and flywheels. So why not just use that? It's actually far better to use a rapid strike pistol cut down thing, or a strife that has an auto pusher if you want that level. You can't make a rapid strike fire 350 FPS as easily as you can do it with an air blaster. I'm sure someone can clip that and prove me wrong.
Epic Whale is basically the epitome of I disagree. Like, his thing is just flywheels. He just
Sure.
jams flywheel stages upon flywheel stages to his blasters until it hits the velocities he wants. And I respect that. Like, that's still labor. It's more labor than I want to put in. That's what I'm getting
exactly.
at.
Yeah. So, yeah. what else? There was one other thing. Oh yeah, we talked about solenoids that fit, a Destiny core sort of system, and just more things. There's lots of 3D printed strifes. All sorts of different shapes. Some people like some people like others. Great. It'd be cool if we could have more people 3D printing things for XBZs or supercores or whatever. Like that would be cool.
And
and also
like,
outsource your manufacturing to China and a quarter the price.
No, I'm not going to China. What? No. I'm very proud of my designs. I really don't want to talk about that one, but it's more of a matter of once it's in the China domain, then bootlegs can be possible, and
that's better for the hobby.
I hate that you're right. I really do.
Question: does tank shape have a bearing on how the pressurized air is expelled? Yes and no. Technically, yes. I mean, everything has an effect on everything. The significance of that effect is minimal. The only thing that's really going to change the performance is flow restrictions. So if you have a bit that's like 1 millimeter in diameter, you're not going to get good flow rate.
Literally any piston attached to QEV system that isn't the piston literally attached to the QEV will have some dead space in the line between the air tank that you use and the piston. That will create a flow restriction. This is where, time and time again, it's going to come back to the supercore being efficient in terms of the piston is the tank.
Actually, the first HPA blaster that I put on page actually used a really massive piston as both the operating mechanism for like the function and the air tank. And I basically threaded, it was a 120 by 32 bore piston. It was really big. And then I had the QEV just bolted straight onto that. And so by filling the QEV, it extended the piston, then it closed the breech. Never ended up finishing it because that's a really bad design. But yeah. Yeah.
Probably one of the, it's like, it's a conundrum. Like you go power versus, size factor a lot of the time with those off-the-shelf components. Like the original Red Baron used a 20 mil bore, 100 mil stroke piston, but by God, like you saw the first firing video when I was whatever, that was a cluster budge of like
that was fire extinguisher days, wasn't it?
That was that was like very early paintball days for me, where I had a terrible second stage regulator. I had so much flow restriction.
You had that 1500 psi reg that was like this big, wasn't it?
Oh no, before that even. Like back when there was a regulator that was this size, it cost like $25 on eBay, and it just the air coming out of it was just all right. One question that probably would be really good to finish us off with: what's the best place for a beginner to learn about HPA? There are two places in mind. First is the Nerf Facebook page of Nerf high pressure airheads. I'm an admin. Answer the questions, prove you're human, and I'll let you in. And the other one is the HPA Nerf subreddit, because Ryan's got a bunch of links there. And when we remember, we should probably update those with relevant stuff. But there is a bunch of good stuff on Ryan's MTB channel. There's a bunch of good...
I would not go to MT, like all things considered. The info that I put up there, I think, is out of date. And I was working with XBZs. That's not the way you want to do this. XBZs are too hard to find. You need a lathe to do what I did, as well as I did it. Definitely go to either the High Pressure Airheads Facebook page or HPA Nerf. I've done some write-ups there. They're like 3 years old, but they're still, the content is accurate. And I guess I could update some of the links, but I don't actually think I put any links in them. But
I mean, I think my introduction to HPA Nerf on YouTube is still somewhat valid for off blaster rigs, and I should definitely get around to talking about these in more detail in a future video. Like I've finally done a build showcase for ADHD, but that was months ago, and my schedule blows out really easily at the moment.
So we had a fun question. What's your unicorn blaster? That's an easy one. What would be your? All right, we just had the voice of God. Hello.
Okay.
Yeah.
So what's your unicorn blaster, Ryan?
It's this one. Straight up. This is it. Once I've done that, I'll be happy. It's a Alfa Romeo that is Nerf.
Yep. Pretty hard to get any further.
Oh no, putting a solenoid in that, and yeah, that's the only way I can make that better.
Yep. And mine is the current blaster I'm developing, because I was designing a blaster about a year ago called Never Satisfied, and that, true to its name, I was not happy with the design as it developed, so I pretty much scrapped that project. But my unicorn blaster is what I'm currently working on, called Creme de la Creme, because I do perceive it to be probably the extent of like what HPA Nerf is capable of, in terms of taking all your fundamentals and adding pretty much ultimate tunability to it. It's I'm aiming to have FDL levels of tunability in an HPA supercore blaster. So that's where I'm at, and I think that we've been asked to finish the stream here. So I'd like to thank everyone that's tuned in for sticking around with my annoyingness and Ryan's gorgeousness for an hour and a half.
Oh, that sounds fun.
Up next is Alice Coatduck and Pandemonium doing CAD 101. So thank you for tuning into the HPA stream, and stick around, because in half an hour you're going to get a lesson on how to design blasters for supercores. If you want the files, ask me. I'm very approachable, in spite of the fact that I'm a major pain in the butt. So please, by all means, come along and actually, ask me, because I'd rather you do things right, and I'd rather help you do it than you go behind my back and make a mistake that I could have helped you with.
Same. You guys know where to find me on Reddit, Rhino Oz, or Discord. Just boot me.
Thank you very much.